Applied's pillars and what we're founded on is top talent, total technology, and absolute adaptability. We pride ourselves on having full-time engineers, not inventor experts or certain CAD platform experts or even contract engineers. We are full-time engineers working on your projects and have great experience in different industries. Also, I'd like to point out that we're an ESOP company, so everybody has a stake in every project. We take more pride in each project because they are an ESOP employee. So again, next thing I'd like to point out is that we're total technology. We do partner with some of the industry's best manufacturing solutions. Autodesk, for example, Sigma, SolidCAM, HSM Works. I can go on and on for different partners, and we really do have a good resource for anything that any manufacturing challenges that come up. And absolute adaptability. Our customers vary from small mom and pop shops to global players, and we have tailored our business to meet and fit your needs. And so we are very adaptable, and whether that be us working at your location or offsite at our location, whatever works best, whatever fits your company, we pride ourselves in being able to adapt to your company. And I will play one more quick video. I want you guys to really understand everything that Applied has to offer. We have a great offering for manufacturing, and so I will push play here.
Whether you're talking about a team of people or mechanical parts of a machine, one thing is certain. In order to work properly, they have to fit. A square peg in a round hole? Nope. Oil and water? Not going to happen. At Applied Engineering, it's our business to make sure that we fit with your plans, people, and projects. We achieve this by combining top talent, total technology, and absolute adaptability, creating a custom solution just for you, when you need it and where you need it. Why Applied Engineering? We thought you'd never ask. You see, the speed of business can be a complicated mosaic of custom software, machines, and computers, and sometimes you need a team of professionals to help you navigate it. That's where we step in. It takes the right people with some of the best minds in the business to help you turn your ideas and dreams into physical products. Our team of engineers will work with your product development team to design your products, fitting within timelines and budgets. Then we work with your manufacturing team to improve processes, design tooling, optimize workflow, and increase efficiency. And to increase overall productivity, our programmers will write custom software to replace spreadsheets, secure your data, and give you the information you need when and where you need it. Our talented team will help you implement industry-leading design and manufacturing software, saving you time and money throughout your design and manufacturing processes. We reduce the paper pileup by digitally scanning your large format drawings and blueprints and making them searchable and accessible. We install and support industry-leading servers, storage, backup, and networking equipment to help keep your data secure, accessible, and efficient. We're the only firm with the talent and technology to fit your project, your process, and your culture. Our ability to be adaptable to any work situation allows you access to our technical experts directly, so support for your engineering and technology systems is only a phone call away. We also offer standard classroom training on a variety of engineering software, as well as customized training to fit your unique needs. Visit one of our training centers, or we'll bring our mobile training lab to your site. By providing engineering and IT expertise, as well as software, IT infrastructure, and training, we virtually and literally support every facet of your product's lifecycle. Applied Engineering is the modern solution to your engineering, design, or IT challenges. Our dedication and commitment to fitting your timeline, budget, and specific project scope is something we stand proudly behind today and have since we started doing business in 1986. We are the only firm with the talent and technology to fit your project, your process, and your culture every time. Visit goapplied.com to learn more about how we can help you or how you can join our team.
That was a great video just overviewing Applied Engineering, and I hope you guys were able to kind of understand how we can fully help your company reach its full potential. With that said, I'm going to jump into the presentation here, Future of Making Things, and let Dan Luby take over. Before he does that, I just want to let everybody know on the bottom right-hand side in the panel, you can ask questions throughout the presentation today. I will be moderating it and handing those questions off to Dan, or I'll try to answer them myself as best I can. throughout the presentation, but if we can't get to them during the presentation, we will hold them to the end, and then we'll ask those questions at the very end as well. So please enter all questions in on the chat or the question box on the bottom right-hand side. With that said, Dan Luby, take it away.
Thank you, Dave. Welcome, everybody. My name is Dan Luby. I am a manufacturing technical specialist with Autodesk. Dave asked me to join today to kind of talk about some of the new technology that we have at Autodesk and that we're pushing out and making available to our customers. And I picked the two that I find the most interesting. But I think before we get into the actual technology that Autodesk is putting out into the market, let me switch over to my screen here. First and foremost, I kind of want to start by looking at the future of making things. And this is kind of like a pretty broad statement, you know, the future of making things. But I think it's important for all of us in the design and engineering world to understand where things are going. Dave talked about earlier, you know, there's a lot of process disruptors out there today. We'll talk about some of those. But in reality, there's always been process disruptors, right? You can go back 20 years ago. There was new technology emerging, like 3D CAD. That was a process disruptor. So there's always going to be process disruptors. The thing I want to point out today is just the ones that we're noticing that are becoming more and more, I guess you could say, mainstream. And then after that, we'll take a look at some of the other topics, automation and shape generator. So I am running, just a side personal note, I just moved into a new house. I'm running off of a MiFi hotspot right now, so it may take a minute for my screen to load at times, so bear with me. Okay, so first and foremost, you know, what are some of the things that you hear in your organization from management, right? From your customers, from suppliers? Like, what's the biggest thing that we all face today in terms of challenges? And generally, it's always going to be, well, we need to be better, faster, and we need to make you know, quicker decisions. We need to be more agile. We need to get to market faster. You know, it's like we hear this all the time, but how do we actually do that, right? And I think, you know, with the future of making things, with a lot of these new process disruptors, they can actually help us to make better, faster decisions, get to market quicker, have higher quality products, and be able to gather information quicker inside of your organization. So first and foremost, for process disruptors, we talk about fabrication. If you go back 10 years ago, how many people were using CAM software? Probably not many. I know there were a few, but today, in today's age, in subtractive manufacturing, or CNC, we're seeing a lot more CAM, right? So computer-aided manufacturing, being able to utilize, you know, computational power to figure out and generate tool paths for parts. Because of this quick nature and the ability to kind of utilize the knowledge of the computer, if you will, we're able to start generating more complex parts of higher quality. If you take that a step further and we take a look at the new additive manufacturing, which is kind of the trendy word for 3D printing, I mean, I think we have all seen this technology just explode. We have the ability now to print composite materials such as carbon fiber. We have the ability to print metals. I know we even have the ability to print organic materials now. Just the other day, I was talking to this baker, and he said he went to this like bakery convention, and there's 3D printers now for cakes. So they're like 3D printing wedding cakes, which I think is just incredible. So I think we all know 3D printing is here to stay. It's kind of past just being a trend, and it's becoming much more mainstream. It's something we use for prototyping all the time. I mean, this is something that helps us create, you know, higher quality products. It helps us minimize the physical testing required, you know, that along with FEA analysis. I mean, fabrication is really coming a very long way. Digital and physical convergence. This is the idea of doing more in a digital world, right? And that connecting with the physical world. In the past, if you think about a typical process maybe 10 years ago, it's, well, let's drop our design, let's generate that design in 2D in AutoCAD, and then let's make that design in our shop, and then let's apply some loads and pressures to it to see if it breaks. Kind of like the old school traditional process. And I know a lot of people are still using that process. But now in today's age, we can do a lot of upfront testing. We can do a lot of upfront visual work for marketing material. We can simulate things before creating those physical prototypes to kind of eliminate some of that. One of the coolest technologies I think that's coming out, and I've seen become more popular in the last, I want to say, 2 years, is virtual reality and augmented reality. And so that is the ability to, I guess, do one of two things. Virtual reality, you're putting your user in a 3D immersive world where everything is computer generated. I've seen a lot of aerospace and automotive manufacturers use this technology to prototype vehicles, right? They have kind of little mock-ups, but they use virtual reality to sit in a car, look at the dashboard, look at the the rear car. They're looking to make sure it's visually acceptable before they even produce anything in the physical world. And then you have augmented reality, where you have folks like in the image in the bottom left who are designing on their computer and then looking to the left at an AR pad to see what that product looks like sitting on their desk, or sitting on the floor, or on somewhere. It's kind of like it's a combination of the physical and the virtual world using augmented reality. And then another big one is just the trend of cloud, mobile, and social, right? Everything being in the cloud nowadays, and being readily accessible from any device. It's kind of pushing out the company server, if you will. Like, you have information in the cloud. I don't have to maintain a server at my company anymore, because everything is in the cloud. It's being maintained by Amazon or some of these big, huge corporations that really know how to manage IT. I don't have to do anything. I can access the same information on my laptop as my home computer, as my tablet, and as my phone. I can get all of this information in real time. And what that does for us in the design and engineering world is it allows us to collaborate much more effectively when we're using these cloud, mobile, and social applications. So there's two things I want to talk about today when we actually get into the technology. With all those things I just talked about, we really kind of think back, well, how can I actually incorporate some of these new trends into what we do at my organization? And so there's two things I really wanted to highlight today. The first being kind of automating the collaboration between sales, design, and engineering. And what I want to talk about here is a tool called Configurator 360, along with Inventor, and how these two work together to provide not only a cloud, mobile, and social application of collaboration, but how we can actually tie in sales to the process. And so if we kind of think about automating this process, think about maybe like your typical bidding process within your organization. You typically would maybe have some sales personnel. They go talk to a customer. They get some information from the customer. They come back, and it's basically the telephone game. They take that information and they share it with engineering or design, and it's a lot of back and forth, right? That's the portion we want to automate here, and that's what I'm going to be highlighting. But before we can get to the automation of sales, we have to kind of start at the bottom. We have to have a solid foundation within our organization to be able to have that type of automation. So if you look at this pyramid, I kind of consider this the automation foundation. You start at the bottom, 2D design and engineering, right? A lot of us have accepted 3D CAD applications, right? Are using Inventor, are using SolidWorks, or whatever it may be that we're using. But before you did that, I'm assuming you used AutoCAD or some sort of 2D application, right? From there, there may even be a combination of use. There's a use case for 2D design still today. There's, I'd say, a lot more use cases for 3D design today with some of what you can do inside of 3D design. But once you have that foundation within the design and engineering department, we can then start moving into design automation. I know there is design automation available for AutoCAD, but what I'm focusing on today is design automation in the 3D realm, specifically Inventor. So in design automation here in this foundation, I'm really referring to Inventor's iLogic. And if you haven't explored iLogic before, I highly recommend that you do. One thing I probably should have done at the beginning is given you a little more of my background. I've been in the CAD industry for about 10 years now, and I've used a lot of different tools. I actually used SolidWorks in the industry. I used PTC, Wildfire, or ProEngineer Wildfire in industry. I used AutoCAD. Then I moved and started working for SolidWorks, and I was selling SolidWorks. When I came to Autodesk and I started getting into Inventor, I found iLogic, and I was blown away with how awesome this technology is. It helps to speed up the efficiency and productivity of your engineers like tenfold. I can't even tell you how awesome this technology is inside of Inventor, but that's really the design automation that I'm getting at here. It's allowing me to program kind of like what-if scenarios into my CAD model, right? And then be able to have a drop-down form that allows me to choose what it is I want my CAD model to look like. So it allows me to kind of configure my CAD model on the fly. And we'll talk a little more about that as we get down the line. But once we have that iLogic built into your model, right, that programming inside of the model, we can then populate that to an application called Configurator 360. It's a cloud application. It allows for online configuration use, right? And this use could be your customer. It could be your sales staff. It could even be your engineering staff. We'll talk about applications as we get there. But this is that original process I was kind of referring to in sales, design, and engineering. Up front, you have sales folks, talking to the customer, capturing requirements of a new design or whatever it may be. Sometimes this can lead to inaccuracies. Sometimes there's miscommunication between your sales personnel and your engineering personnel. But once that information has been passed along, engineering gets involved, and this can be a very long manual effort depending on what it is you're selling. If it's a large-scale, customized machine or something small, this process could be the bulk of this actual bidding process right here. And it ends up turning engineering into somewhat of a, especially if this engineering group has to produce, drawings or anything that needs to go back to the customer in order to make the sale. So it really kind of bogs down this whole process. If we move into cost estimation, right, sometimes this can be inconsistent. You can have folks in estimation who have to take information from engineering, take information from sales, and then manually put that information into another system, such as ERP. Right? A lot of the time this leads to duplication of data. It also leads to errors. Unfortunately, we're human. We make errors. And then finally, the proposal development. A lot of the time this is a manual effort, putting something together for the customer. It's very manual, text-based, not very intuitive. It's here's your packet of everything with all your requirements, and sometimes they can look good. And I'm not saying they're ugly, but we can do this a better way, and that's kind of what I want to get into today. So if we look at this whole process, we have sales automation kind of capturing this whole workflow, whereas the design automation portion is really for the engineering and design group inside of product configuration. And again, I mentioned earlier the two products I'll be discussing or demonstrating are Inventor plus iLogic, and then Autodesk Configurator 360. So what I'd like to do here is let's go into Inventor to start. And what you're looking at here is just a wheel, right? I have a wheel assembly inside of Inventor that I designed. It has a few top-level components. It has a top-level subassembly, and this can be kind of broken down in terms of hierarchy. But what I'm really getting at here is iLogic, right? So after I've designed something like this, I have iLogic, and inside of iLogic, I have rules. So a rule could be something like, if I change the diameter of the rim or the tire itself, then these other parts have to change size. If I change it to X, then these other parts change to Y. Right? We start driving with almost the use of equation of how this will work. And inside of that, I can even have pricing information. So you see here I have like a pricing rule. So, as the user configures this wheel, if I have 8 spokes, it's X amount of dollars for this. If it's 5 spokes, it's X amount of dollars for this. If they add slots in those spokes, it's X amount of dollars for this. Right? We can start to add in some of this pricing information. You can even tie this into other business systems, right? Because iLogic can utilize Excel. I've had a lot of customers who take their ERP system, publish out pricing information, because we all know that changes. They publish out pricing information into an Excel document, into a specific folder location, and boom, iLogic grabs that information off of Excel and is current, continues to update pricing from the ERP system. So if I look at this actual form, what I want to do when I configure a model is I want to make it easy for my downstream user. So here, I'm noticing that my screen hasn't quite updated yet. Let's see here. Hey, David, can you verify? Can you see that I've opened up an iLogic form? Oh, there it is. It just popped up.
Yep, we see it.
Okay. All right. So once I've opened up this form, this is really an application inside of Inventor for many different things. I'm discussing the use of iLogic, for design and sales automation being pushed out to Configurator 360. But I've seen a lot of customers use iLogic for many different things. And without the use of Configurator 360, let's say we take out the sales automation, right? We just talk about design and engineering automation. Inside of your company, I'm sure you probably have folks who have been there for a very long time, and those folks have a lot of, for lack of a better term, tribal knowledge, right? They have a lot of experience with the products. They know what works. They know what doesn't work. How do you capture that experience from your users? How do you capture that information? If Joe, who's been at Acme Co. for the last 30 years, who knows everything, if he leaves, where does that knowledge go? It may stay in some of the data that he's created on your network drive, but if we do this, then we have to do this. That type of experience and knowledge can be programmed, into your model using iLogic. So it really kind of captures some of that tribal knowledge when you start to utilize this tool inside of Inventor. So to give you kind of a little preview of what happens here inside of this form, it should be pretty self-explanatory. It's pretty easy to understand. If I change the wheel model from size 22 down to 18, I change the spoke size down to 6, and I turn off the slots and I hit apply, here's what happens, right? Inventor sees what I've done, it goes into my rules, and it understands that if these all change, then this has to change, right? And then it just republishes my new CAD geometry. It also, you'll notice here, the total prices are read-only. It's taking into account the information I've put into this form and giving me kind of an estimated price of this wheel or this configuration of this wheel. So that is really the iLogic portion inside of Inventor. When we want to push this out, right, and we want to make this accessible to other types of users, right, outside of engineering, that's when we can get into more of the Configurator 360 application. So inside of Inventor, you have a button that allows you to publish your design Configurator 360. And the first thing you'll notice here, I'm on the back end of Configurator 360, signed in as an administrator right now. So this is the administrator's view. And you'll notice right away that this is built into a browser, right? So this is your cloud. This is your mobile accessibility to that same configuration that you were seeing inside of Inventor, only now it can be accessed outside of your four walls of your organization. It can be accessed on your phone. It can be accessed on your tablet, on your work PC. You can even embed this into your website and have it do configurations directly in front of the consumer. So you can have the consumer basically log on and say, oh, I want to configure a wheel. So I'm going to go through and I'm going to choose exactly what I want. It's a more interactive experience for your actual customer. Now, some folks don't go that far in giving the configuration ability to the customer, but they do give the configuration ability to the sales folks, right? So sales folks will go in, they'll sit down with their customers, and they'll do it together, right? Maybe on an iPad or whatever, and they'll be able to configure this live with their customer, making sure they get all of the requirements, because they're basically going, down a form A to Z. So you'll notice in here I have almost like a product catalog. And me, I give a lot of demonstrations of this software, so I have a bunch of different types of data being shown in here. But at the very bottom, I have this wheel assembly, the same exact model you saw inside of Inventor. And on the back end as an administrator, I can see the number of sessions that have been initialized, right? How many people have gone in and actually configured this model. It's nice to be able to get some metrics to see what's most popular, right? So you start to build off of other data that you get inside of this configurator to understand which products are more popular than others. But if I go to the actual view that the consumer would see, I'm going to click on this Go to Design, and this is going to open up Configurator 360. And what you're going to see here is the wheel in the center of the screen. So I'll kind of zoom in a little bit here. And if I let this sit for just a second, this is actually being run on Autodesk servers. Autodesk does not have access to your data. It's a secure location that only the administrator of your Configurator 360 tenant has access to. So as this updates on the screen, you'll notice on the left-hand side I have 3 buttons. The very first one are the options I have to choose from. The second one is the ability to download information. So I'm still waiting for the screen to update. I've kind of already clicked through some of this stuff. But what we have here is somewhat of a sales tool, right? We have the ability to gather the requirements. We're giving the end user the option to download, and we specify what types of downloads they can get, right? Can they get the pricing information? Can they download an Inventor assembly file? Can they download a step file, right? Think of all the opportunities you have to utilize that download option. When you have customers calling you saying, hey, we really like your product, but we want to have access to 3D CAD models because we want to be able to your product into our design. How do you guys do that today? I feel like a lot of the customers I talk to are, well, give us a call and we'll have someone from engineering produce a step file, and then that person will email it to you. That's pretty common, and I think it's pretty cumbersome. You're taking time away from the engineers for a very mundane task. It's an important task that needs to be done, but is it really something that engineering should be doing? Configurator 360 gives you the ability to kind of eliminate that, automate that process. So exactly what you're seeing here. I have all of my options listed here, even some additional ones inside of Configurator 360. The ability to choose my brake material, my wheel finish. You can group these into little, you can group each of these parameters into different sections, right? You can also have cascading drop-downs. So if I choose this, then my next list has to be these items, right? So you can start to build out whatever your form is that sales goes and talks to the customer with. You can take all of that information, you can build it into this interface. Now what you're seeing here is the generic Configurator 360 interface. You absolutely have access to this out of the box when using Configurator 360, but you don't have to use it. A lot of folks will take portions of this interface and embed that into their website. So you can take the 3D viewer, you can use get and set commands on the parameters that you see on the left-hand side of my screen today. It's up to you how you actually, I'd say, roll out this automation function. So once I've configured my model, below that I can go to output. You see here on the list on the left-hand side, I've chosen to allow my users to extract BOM information, which comes out in text format, right? Below that, I'm giving them the ability to download the Inventor assembly. I have IJustStep STL. You choose what download types. There's many more than this, but these are the ones that I'm showing today. Notice at the very bottom, I even have a quote button. So let me click this. This will probably take a second to download to my machine. But what it's doing is this quote is looking at all of the parameters I put in. It's looking at the graphic in the middle of the screen. And now if I open up this quote, you can see I have like a default kind of template code in here, but yours would look different. It's giving me all of the requirements that I put in. It's giving me the price, right? This is incredible to be able to automate this process, right? This could be the sales rep on the phone with the customer or sitting next to them, helping them configure the product, putting in requirements, and then pulling down the appropriate pricing information right there on the spot. Again, pricing information does not have to be incorporated into this tool, but I feel like that's a very powerful thing to add if you have the ability to do so. So that is Configurator 360. Again, you can access this anywhere you have an internet connection. Right? So again, tablet, mobile device, laptop, computer, it doesn't matter. As long as you're connected to the internet, you can access this configurator. So again, like we mentioned earlier, if you have questions throughout any of my portion of the presentation, feel free to type them into the chat window. We'll try to have someone answer it as we go. Otherwise, at the very end, I'll jump into there and I'll grab questions and I'll respond to those. So I'm going to back out of here and kind of go to PowerPoint and move into that next piece of technology that I think most people are on this call for, to be honest with you. Generative design and shape generation is very neat technology, and it's making its way into mainstream, just like that configurator tool. If we kind of move to the next slide here, we have, Shape Generator is a tool that allows us, it basically aids us in design. I don't want to say that it's going to design for you. It's getting close to that Staples easy button, but it's not quite the easy button yet. What this allows us to do is it allows us to take a block of material inside of my assembly, right? I know this block of material or this thing is going to be fixed here. I know a load is going to be applied here, right? With those real-world conditions, I'm able to input that into Shape Generator, and what it will do is, using a NAS transsolver in the background, it will gather the most rigid shape it can find to support the force and the fixtures that you've put into that blob of material, right? So it sounds kind of like mundane, but when you really think about it, it's optimizing our design, right? It's using FEA in the background for us. We're not having to do FEA to find the shape that we're looking for. We're allowing the computer to do it for us. All we're doing is putting in real-world conditions. So what does this do? It allows you to optimize design and iterate very quickly, right? I know that if I use Shape Generator, I've come to probably one of the best shapes I can get or design for this particular part or component, right? And it allows you to be more innovative. Now, some of the shapes that come out of Shape Generator are not going to be prismatic. Actually, most of them will not be prismatic. And if you think downstream about manufacturing, it can be hard to design. It's like, where's the trade-off, right? It's great that I have this tool to help me be productive up front in the design process, but downstream, when I actually go to manufacture this thing, this shape is so weird that I don't even know how I'm going to manufacture this thing. There's a fine line in between right now, right? But again, those process disruptors, thinking about 3D printing and how we can start to print metals and all these various different materials, Shape Generator, along with 3D printing in the future, is probably going to be pretty popular, right? When these metal printers and composite material printers become more readily accessible and they're not so expensive, why wouldn't we start doing these more organic kind of shapes that match our requirements, but also are the most lightweight part possible? I mean, why wouldn't we do that once it becomes more inexpensive? But in the time being, you can kind of I kind of look at this Shape Generator inside of Inventor as more of an aid in the design process. So let's take a look at that, how that is actually done inside of Inventor. So I'm going to come to this Inventor assembly. I'm trying to minimize the movement on my screen, especially in CAD, because I know that if I go to rotate and it looks nice on my screen, for you guys, it's going to be just a blurry mess. So I'm going to try to minimize as much as I can. What we're looking at here is an ASCA jig assembly that's holding a sheet metal part. And if you look at, let me kind of zoom in here. If we look at this component here, this one hydraulic jig on this left-hand side, I mean, it's many of the same, but if we just look at this one, notice this block, this kind of green block in the middle. That is one enormous kind of structural member inside of this jig. And there's some forces being applied to this. The jig is actually coming down on top to clamp down on this sheet metal part. Wouldn't it be nice if we could just kind of remove some of that material? And most folks would say, well, yeah, I'll just put a hole right in the center of it. Like, yeah, you could do that. Absolutely. You could run some FEA on it afterwards to kind of verify. But, you know, is putting a hole right in the middle actually the best place to put the hole or to remove material? You know, that's where Shape Generator comes in. I can take this bracket. Let's actually open this bad boy up. But what I'll do is I'm going to come into this individual part. I'm going to turn this to the side a little bit. I'm going to let my screen update for a second. Sorry, guys. My Wi-Fi I thought was pretty good, but it doesn't seem to want to update very fast. Okay, so I've seen it. Okay, so we're there. So here's my part. Again, I know that I'm clamping on this top little kind of extrusion in the upper right-hand side of my screen. What I'm going to do inside of my part is I'm going to go to Shape Generator. And what this does is it actually almost opens up. It's basically prompting me. Let me see here. I just pulled this part out of Vault. Okay. So it's actually bringing me into somewhat of a FEA-looking environment. For those of you who have used FEA, you even see kind of like an FEA type of icon, and it says analysis in my tree on the left-hand side. But really all we're doing inside of Shape Generator is we're working from left to right. Just like all of our FEA tools, we start by assigning material. So I come in here, I'm going to assign just an alloy steel material. I'll come down here and choose that. And this may be a little behind. I'll try to go as slow as I can. Once material has been applied, then I can come to constraints. So where is this thing being fixed, right, in the real world? In its real world condition, it's being bolted to brackets that are attached to the skid. So I'm going to grab these 6 holes here, and I'm going to say these are fixed in place. Okay, so we know where that thing is being fixed. Next, now where is force being applied? Well, I know I have almost like a piston over here, and we'll say that this piston is putting on 1,000 newtons of force. So we'll apply that. And then at the very top, we have these 4 holes that have additional forces being applied at each of these faces. And here you'll notice my force is at an angle. I can specify an edge to make sure that these forces are going down. And here we'll say the magnitude is, we'll say 300. Right, so again, I'm just applying my real world conditions. Now, I could run this right now with Shape Generator. What it's going to do is it's going to maintain the faces that I've selected. Right, so I've selected where the forces are being applied. I've selected where this part is going to be fixed, and it would maintain those circles and those holes. But I want to make sure that there's more material around those holes. So what we have after we apply force is we have preserve region. And so what I can do here is I can choose an edge. And what this does, and it may be kind of hard to see here, but I can actually choose material that's in my quote-unquote blob to maintain. So what I'm going to do here is we're going to make this box a little higher. I'm going to change the height here to, let's go 90. And I don't know if you guys can see this. It's probably kind of hard to see, but I have this kind of like kind of highlighted green area. This is almost like a keep out. Like, hey, when you go to remove material, don't remove any of this material. So I'm going to apply. Then I'm going to come up here. I'm going to choose this edge right here. So I'm going to grab preserve region again. You'll notice when you grab an edge, it makes the appropriate diameter. So I'll apply that one. I'm going to come up here, grab this top face, Let's move this one down 70 or so, just to make sure that we're capturing where that clamp is actually coming down. And then very lastly, let's grab this circle here. And by default, when you grab a cylindrical surface, it wants to make a region that's cylindrical. But I want this to be a box, and I'm going to change size and shape to about 15 wide by, let's say, 80 tall. Right, and so it's now capturing kind of this region over here. Hit apply. So once I've done my model, right, I've fixed it in place, I've specified the loads, and I have specified the keep out section for removing material. I'd say the very last thing is to come into your shape generator settings. One thing I want to point out here is this is my objective, maximize stiffness. This is today, right? This is the first time this technology has been put into Inventor. This is our objective today. But if you notice, and I can't say much more, this is a read-only drop-down list. Nothing else is in the list today, but I'm going to allow you to imagine that this could potentially expand into some other types of objectives in the future. So here I have reduce original material by specific percentage. So let's just choose, I want to reduce 40% of the mass, right? So I see my original mass, calculating the current material, and it's going to give me my mass target of 3.44. So I'm going to say OK, and all I'm doing now is I'm generating the shape. So I just hit run. I let the software do the work. So what this is doing, it is an FEA environment. Again, Nastran is running in the background as the solver. It is meshing this model into tiny little geometric shapes and then running kind of like algorithms and calculations on those shapes to figure out where those loads will move through the model, and where they are not removed, where those loads are not moving through the model, that's where it begins to start to take away material. And so what we're left with is this very kind of semi-organic shape, right? There's a little bit of prismatic nature to this shape, but that kind of goes back to when I was saying, you know, this is an aid in the design process, right? I already now can look at this and say, oh, this actually makes perfect sense, like why this would be the shape, you know, with the loads that are being applied to this thing. So this is kind of a very simple example. This was a prismatic shape to start with. It wasn't anything, you know, very lofty, curvy surfaces, but you probably wouldn't do a lot of the lofty, curvy surfaces until you did the shape generator. So I hope that this kind of helps you look into the future of, hey, you know, this is something small right now, but this is something that could really help us, right? I know that the aerospace and automotive industries are becoming fanatical about this type of technology, right? Because they're super into lightweighting components, but I think you guys will find that this is a very powerful technology. It's, you know, new to Inventor, not new itself, but it's something I really recommend you try. You know, I've been in the CAD industry for 10 years. I had never really used a shape generator before, and when Inventor received this technology, I came in, I didn't look through any tutorials, because I always like to see that, like how hard it is when I first do it. And so I didn't look through any tutorials. I just came into this interface, and I worked from left to right, and I took like I just made like a circle with a couple, like a hole pattern in it, and then put some radial loads on it or whatever. It was so easy to use. I couldn't believe how easy this tool was. And so I highly recommend that you try this technology as soon as you get a chance when you're running Inventor 2016. You know, very lastly, this is an FEA environment, but I want to warn you that you still need to run a simulation after you've generated your shape. If you notice in the settings, I can choose to reduce the original percentage by whatever I want. I could say 99%. What do you think that's going to leave me? Do you think it's going to leave me a structurally sound bracket for this machine? Probably not. So, you know, you can't eliminate real FEA analysis after using shape generator. So keep that in mind. But with that, that's what I had for today. Let's go back into the actual PowerPoint. Oops. Where am I at here? Sorry, I got too many things open. So at this point, I guess we'll kind of leave it at Q&A. Please feel free to type out any questions that you may have, and we'll take a look at some of those questions.